Hello everyone, in this video we're going to talk about a very important concept in statistics called the z-score or a standardized value. Let us suppose you have an observation, a data value which is x. X is the data value, and what we want to do, we want to find out its z-score. How we define the z-score? Let x is any observation. The z-score for x shows how many standard deviation above or below an observation is from the mean of the observation. Right? We have any observation, any value x. The z-score of x tells you if an observation is above the mean or below the mean. Now, in order to understand this idea, I will give you an example, like a simple example to understand. You will get an idea. Let's say that you are living in a tall building. Like you are living in a building with multi-floor. You are here. This is you, right? And here I am. You are, let's say, on the 10th floor. And let's say I am on the 15th floor. Let's say, right? You are on the 10th floor and I am your professor living in the 15th floor. Now you tell me you will be able to tell me very easily, am I located above you or am I located below you? Clearly, I am above you. Okay? And above you, how many floors? I am above you 5 floors, right? 11, 12, 13, 14, and 15. I am above 5 floors. Let's say your friend lives here. He is, let's say, on the 5th floor. Your friend. Here, this was me. This is your friend, and he is on the 5th floor. Now, clearly, your friend is below you. He lives below you. And how many floors below? He is exactly again 5 floors below you. So by looking at this example, it's very easy to understand this. The same idea exists here, right? The z-score of an observation tells you if a value, right? In this situation, we were talking about the floor, but now here no floor. We're talking about a math now. The z-score of an observation tells you if an observation is above the mean or below the mean. And if it is above or below, how many standard deviation? The yardstick is the standard deviation. Here the yardstick was floors. We were counting, okay, my teacher is 5 floors above. My friend is 5 floors below me. But here the yardstick is the standard deviation. If an observation is above the mean or if an observation is below the mean. Remember, the z-score can be positive, z-score can be positive, or z-score can be negative, or z-score can be 0. If the z-score is positive, then an observation is always above the mean. If the z-score is positive, then observation is always above the mean. And if the z-score is negative, the observation, the value is always below the mean, right? Below the mean. And if the z-score is 0, the observation is actually the mean. It is the mean itself. The value is the mean, right? So that's how you can identify where is it tells you the position. It tells you the position of an observation with respect to the mean. If whether a value is above the mean or if the value is below the mean. Okay, if it's above or below, how many standard deviation? The yardstick is the standard deviation. The next question that comes to the mind, okay, how we're going to compute the standard the z-score? It's very easy. The formula, if you're dealing with the sample data, this is the formula. Z is equal to the value minus the mean divided by the standard deviation. This x bar is called the sample mean. This is the sample mean. And this S is the sample standard deviation. Sample, basic symbols, standard deviation. And if you are dealing with the population data, then you use the formula x minus mu. This is mu This is called the population mean, and this is sigma, which is called the population standard deviation. Remember these two symbols. Remember, mu is the population mean and the sigma is the population standard deviation. These two are Greek symbols you need to remember. Another important thing you need to remember, when we do this computation, we always round. If we are getting a decimal, we always round the decimal to the two. We always round it to a 2 decimal places. That's the thing you always need to remember. We always round the things to the 2 decimal places when we're doing the computation for a z-score. Okay, in order to understand the idea, we take an example. A population of interest has a mean of 100 and a standard deviation of 15. Find the z-score for, we have 3 cases, 130, 145 and 85. So I will do the computation and I will show you how the computation is implemented, how we do the computation, right? There is also Excel command available for that, but I show you the hand computation. Let's do. So the idea, we're going to use the formula z equals to, that's a formula, it's x minus mu divided by the standard deviation, right? In our problem, this is the value for which we want to compute this the z-score for. So this is our x value. This is x. This is our x. So this is 130 minus, this is mu. This is our population mean, mu. So this is 100 divided by standard deviation. The standard deviation, this is 15, is our standard deviation. It's 15. So 130 minus 100 is 30 divided by 15, and the answer comes out to be a 2, and I'm writing a plus 2.00. It's okay, I can write 2 or a plus 2. So z-score of this one is a plus 2. Let's move to the second one. Let's move. But before I move to the next one, I want to make sure you understand. You might be wondering why I put a plus sign here. I want to emphasize the fact that this z-score is positive, right? It means this observation 130 is above the mean. Okay, I will show you in a minute. Now let's do the second one. We have it's the same formula, z equals to x minus mu over sigma. We have x is equal to 145 minus 100 divided by 15. This comes out to be 45 divided by 15, and the z value comes out to be a plus 3. Now this is the z-score for this observation. Look at this, a plus 3, right? And this z value is a plus 3. The z-score is positive. It means this observation is also above the mean, and it's above the mean. It's above 3 standard deviation. This observation is above 3 standard deviation. 3 standard deviation above the mean. This observation was above the standard deviation, but how many standard deviation above? It was 2 standard deviation above the mean. This 2 standard deviation above. This is a symbol. Let's do the computation for this one and let's see what happens. We have again a z equal to the same formula. We have x minus mu over sigma. Our x, this is x value. Then third case, this is our x value. So our x value is 85 minus 100. The rest of the values are the same, is divided by 15. This is 85 minus 100 is minus 15 divided by 15, and the answer comes out to be minus 1. So here z value comes out to be minus 1. This is the z value, right? Z value. So this z value, his z value is a minus 1. It means this observation is below the mean. Why it's below the mean? Because it's a negative. Its z-score is negative. So this observation 85 is below the mean. It's below the mean. And how many standard deviation? It's a 1 standard deviation below the mean. It's the 1 standard deviation below the mean. So remember, the z-score tells you if an observation is above the mean, if an observation is above the mean, and this z-score tells you how many standard deviation. The sign tells you if it's above or below. It's a positive, it's mean above. How many standard deviation? 2 standard deviation. Again, the z-score is positive, it means the observation is above the mean. How many standard deviation? 3 standard deviation. And here the z-score is negative, it means the value, the observation is below the mean. How many standard deviation? It means it's a 1 standard deviation below the mean. I hope you understand that. Okay, the z-score also can be useful in determining the relative standing. Right? The z-score can be used as a measure of its relative standing among all the observation of a data set. Right? In order to understand this concept, we have taken an example here, and let's see an example. Which of the score has a higher relative position? A score of a 299 on a test with a mean of a 260 and a standard deviation of 26, or a score of a 42 on a test with a mean of a 40 and a standard deviation of 4. We assume that the distribution being compared have approximately the same shape, right? So what we are going to do, we're going to consider these two scenarios one by one, right? Let's see the scenario. The first scenario we see. The first scenario says, let's say this is the first one, the first situation. In the first situation, our x value is 299. The mean mu, let's say, is 260, and the standard deviation is 26. So we find the z-score. The z-score is equal to x minus mu over sigma, and that is equal to 299 minus 260 divided by 26, and that z-score comes out to be 1.5. Okay, that's the z-score we have found. We do the second situation here. We do the second calculation here, second one. What happened in the second situation? In the second score has a value of 42, and with the mean on a test, the mean score was 40 with a standard deviation of 4. We apply the same formula. Z is equal to x minus mu divided by sigma. This is equal to 42 minus 40 divided by 4. The answer comes out 42 minus, it's a 0.5. So the z value comes out to be 0.5. Now what we are going to do, in order to decide which score has a better relative standing, we have to compare the two z-score. The two z-score. Larger the z-score, the larger will be the relative standing. Note that here z is 1.5 and here the z is equal to 0.5. This value, this z-score is larger, so this score, a score of 299, has a higher relative standing, as compared to a score of 42. This has a lower relative standing if we compare with this one. So we will say a score of 299 has higher relative standing, has higher relative position, as compared to a score of 42. So this z-score can also be used to find out the relative position of the data values. Where is the relative position? We want to compare the relative position of the data values in this way. So I hope you understand this. If you have any question, please write me an email. Thank you very much.